Hello and welcome to this instructional video on CATIA prismatic machining. We're in the process of machining the second setup, creating the operations to machine the second setup, and we've done quite a few operations which are seen here in the tree. So facing, profiling, and two-pocketing operations on this part of the part. What we're going to do now is transition to this part, this other side, and on this side there are some pockets that features that need to be machined using what we refer to as open pockets. So those are pockets that, unlike the ones that we did on this side, do not have a set of walls that enclose the volume to be removed. And that actually makes things easier from a machining point of view because it allows you to approach the volume from the side. You don't have the issue of having to bring the tool in from above. So let's look at this. The volume of the feature that we're going to start off machining is this one here. So it's really a step, but the best operation that we can use in prismatic machining to remove this volume is a pocketing operation. Now to do this, one of the things that you would notice here is that the geometry that you need, that there's nothing that is exactly what matches the basic shape of this step or pocket. We have, of course, the stock boundaries, the edges on the stock. We have edges on the part, but there's nothing that actually matches up exactly with what we would want to define the geometry of this shape. So typically in a situation like that, what we may end up doing, I'm going to hide this green volume, is we often go ahead and we create sketches. So here's the part. So there's a sketch here that I've created, and this sketch defines the geometry, or defines the geometry that will make up the guide curves, or the guide surfaces of the pocket. So this sketch is set up by probably extracting and trimming information from, projecting and trimming information from the part and the stock. So you may find yourself having to do this. Sometimes it's just an easier way to help you define the geometry. Okay, so let's go ahead and go back to our PPR3, and in this case here I'm going to go into the part, which is this part body here in the, or part here in the assembly, and I'm going to go ahead and unhide. That's the wrong one. Yeah, so we're going to use this to help us define the geometry. So let's go ahead and insert a new pocket. So here's our pocketing tool, and that's inserted after the pocket on the last pocket on the side of the part. So again, if you look at the definition window, one of the things we did before was we toggled this from an open to closed pocket. We don't have to do this in this case because this is actually an open pocket here. So let's go through the same procedure as before. Let's select the top of the part, which again remains to be this surface here. The bottom that we're going to go to, so let's look at this. Notice that there's this island that sticks up. So just as we did with the pocketing, the closed pocketing over here, where we had to use this as an island, we have to use this, sorry, this as the bottom, we have to use this surface here as the bottom of our pocket. So let's go ahead and select this. And again, it assumes that the boundary of this is the guide we want to use, which is wrong. So let's remove this. And then for our guiding elements, we want to select the edges of this sketch. So let's go around and select those. Hit OK. Now, one important difference between defining the pockets, the closed pockets, and the open pocket is we have to tell CATIA exactly which sides of the geometry, which driving elements or guiding elements comprise the open side of the pocket and which don't. And in this case, that's particularly important because we have used a sketch, so there's no way that CATIA can know just looking at these sketch edges which is open and which is closed. To turn a guiding element from a what we call a hard boundary, so hard boundaries refer to boundaries that the tool cannot go through, versus a soft boundary, which is a boundary that the tool can go through. we have to click twice on the element. So if you click twice on this edge here, it turns from a solid line to a dashed line, meaning that this is an open boundary or a soft boundary. The tool can go through this. So let's repeat that on the other 3 edges. Now we don't want to make this a open or soft boundary because this boundary is right up against this face or the side of the part. If we made this open, then the tool would feel that it had the liberty to move through it and would end up gouging this wall here. So we want to keep this as a hard boundary and leave the other 3 as open or soft boundaries. So that's pretty much what we need to define as geometry. There are no islands here. Let's move on to the tool. Again, the tool is going to be the same tool that we used over here. We're going to just use the 1/2" end mill to machine this region, this feature. And we're also going to leave the speeds and feeds, which is on the 4th tab, the same. So the 120 inches per minute for roughing and the 20 inches per minute for finishing, and the approaches as we set it here. The approaches and retracts, some of these have been copied over, notice, from the previous operation. So again, we can look at these. We probably have to modify these. Again, using helical approaches is not necessary when you have an open pocket, because you can come in from the side, which is always preferred. So, but let's go ahead and generate the toolpaths first before we come back and modify these. So let's go over to our first tab and look at our strategy. So our strategy that we used previously was outward helical, and we can certainly do that, but we also have the option to start off the part and to zigzag across. So why don't we go ahead and change our strategy. Instead of an outward helical, let's do a back and forth, so that the tool moves back and forth. And once we see how the toolpaths generate, we will reorient those toolpaths so that the cutter is moving, let's say, from the top of the part to the bottom, or vice versa, and stepping over, working its way from this side of the part towards this region over here. Let's look at our radial options. We have 30% overlap. I'm going to reduce this a bit. Let's go to 10%. So again, this means that this is the amount of overlap that we have, 10%. And then overhang refers to, again, since we have an open pocket, how much overhang do we want to have? So again, right now it's 10%, so it means that the tool isn't going to be that much overhung. I'm going to move it back to 50%. Again, there are going to be quite a few toolpaths here because of the size of the tool and the distance that it has to move through. Let's look at axial. Again, we're going to go to 50 thousandths. CATIA calculates the amount of passes needed, the amount of levels needed, the difference between the top of the part and the bottom. And then for finishing, this is a little bit tricky in this case because, of course, you don't want to finish anything on an open or soft boundary. We may not want to finish this surface right now because in our machining strategy, if you recall when we discussed that, there's this final step here that we want to machine at the end, and it might be a good idea to leave some material here so that we can finish that as part of that feature. So how would we do that? How would we leave material on this face so that it can be machined using a later operation? Well, to do that, we have to go back to our Geometry tab, and then there's this option here to have an offset on hard boundary or offset on soft boundary. This is a hard boundary, so let's go ahead and let's leave some material here for a finishing pass. So let's go ahead and double click on this, and let's leave 10 thousandths material here. So we're not going to completely remove material here as part of this pocketing operation. Let's hit OK. Also, to the top of this island, we can certainly add a finishing pass on the bottom, but we'd be wasting a lot of time cutting air. So I would probably instead leave some material here, and then come back in with a more localized operation to clean up the top if it needed to be finished at all. And to do this, what we would do is we would also do an offset on the bottom, meaning that the toolpad won't go all the way to the bottom surface. So if we double click on this, we can leave an offset of 10 thousandths. So there will be 10 thousandths left on the surface that we can then machine using a more efficient operation. So let's go ahead and hit OK. And let's go ahead and generate our toolpads. Actually, let's go back to our first tab before we do that. Because we don't want to finish, we want to toggle this to no finishing passes. Since there's nothing to finish on the bottom, since there's left material and nothing to finish on the sides. Let's go ahead and generate. And there we go. We see, we rewind and generate our tool. Let's see, we run it through. We see the tool is starting here and working its way this way. And then we have some repositioning moves and so on that takes place at the end of the pad, moving back to the start of the pad. As I said at the beginning, what we'd like to do is probably start here and work this way. So instead of working the tool towards along the x-axis this way, we want to work it along the y-axis. So how will we do this? Well, we can do this again on the Strategy tab by selecting these directions here. So this is the step over direction and this is the feed direction. So by selecting these, we can influence the way the tool moves back and forth across the part. So I'm going to pick the feed direction, and I'm going to pick an edge that lies along the y-axis so that the feed direction, now the primary feed direction, is along the y-axis. So notice it changes, J1. Let's go ahead and generate the toolpaths. So now we see the toolpaths are moving now left to right, or sorry, along the y-axis direction. Also too, we can see that this is dark blue here, so the tool is retracting here and then repositioning. So this is where the tool appears to be starting and then working from the bottom, this corner here, towards the, which is better. We didn't want the tool starting here and working this way, which was where the tool was starting before. If we did that, the tool would be cutting a channel, and it's never good to do this. To do that, it's better to start on the free end and work towards a wall if that exists, as it does in this case. We can again go to our plane by plane replay and then rewind just to kind of see what's happening on each level. So there is our, if we look at our approach, we can see that if you look carefully, and again, CATIA does this strange thing of having, when you do level by level, it puts the approach as gray. So this should be yellow, but this is a helical approach into the start. And then at the end of the move, it does a retract, rapid, back across the part, and then it does a helical approach into the second level, and so on. So again, the tool is lifting over here in this corner. So this is not the worst strategy in the world, but we may want to, if we go to look at it more from above, we may want to have a retract that gets the tool off the part before it lifts and then repositions on this side. And rather than a helical lead-in, it might be more beneficial to use a arc lead-in, since we have all of the space out here to bring the tool in. So let's make those modifications. Also I'm going to go all the way to the end of the toolpath. Notice that there's no blue here. And again, remember, we set it so that it would not create a finishing pass. So let's hit OK here, and let's go to our macro tab. And what we're going to do here, these are not really at play, the finish pass approach and retract, because we don't have a finish pass. The ones that we need to be concerned about are the initial approach, final retract. So let's go ahead and remove this helix for our initial approach. And let's add a arc lead in. And then for the retract, it looks like it does have an arc lead out and a move to plane, which is probably this plane up here. Let's just see what that does for us. Let's generate, and we can see that we now do have, if we rewind and step through, we do have this arc lead in now. I'd like to have this on the opposite side though, so flipped, and then maybe also have a little bit of a, since it's always a good idea to have some axial control of the tool at the approach rate, maybe have a short axial motion at 75 thousandths of an inch, slightly greater than the depth of cut. So let's do that. And actually, before we do that, let's look at the final approach, final retract, sorry. So the tool is in fact coming off the part, and then it's doing a retract up to this plane here. So that's reasonable. So let's hit OK. And what we're going to do for the initial approach is we are going to add an axial move, and we're going to set this to greater than the depth of cut, which is 50 thousandths. So we're going to go 75 thousandths. And in order to flip this side of the approach, of the circular approach, what we do is we double click on it. And if we look at what these mean, the angular sector, the angular orientation. So the angular orientation is really the plane that that particular arc lead in lies in. So if we want to have it on the opposite side, we want to flip it 180 degrees. So let's go ahead and change that from 0 to 180. Okay, let's generate our toolpaths. And we can see that now the tool is coming down over here. There's that 75 thousandths axial approach. Here's the arc lead in that we flipped. And then the tool comes onto the part. So that's the strategy there, and I think that that's probably a good strategy for us to use for the approaches for each level too. So let's go ahead and hit OK, and let's go to return between the levels approach, which is set to helix. If you're watching closely, you would have seen that was the case. Let's go ahead and delete this, and let's go ahead and add our arc lead in. We probably want to flip it, so let's double click and do 180. Sometimes you don't need to flip it, so I'm assuming so, but we can always switch it back if this is not correct. And then let's add our axial move, and let's set this to 75 thousandths again. Let's go ahead and generate our toolpaths. And yes, so that is correct. And then for our retracts, so right now the tool is still for the return between levels, it's retracting upwards. In this case, we can just maybe move the tool outwards a little bit along a horizontal move, just so that it's no longer on the part when it lifts up, so it's clear of the part a little bit. We don't have to do too much there. So for our return between levels retract, let's go ahead and remove this, and let's go ahead and do a tangential move. And let's say we want to move it half the cutter distance, half the cutter diameter, so that's 0.25. And then we do an axial lift up 75 thousandths. Let's go ahead and generate the toolpaths and see what that does. So if we zoom in closely now, we can actually see that there is this blue horizontal move, which is tangential to the toolpath, which is half the diameter or the radius of the cutter, and then the tool lifts up and then rapids over at the rapid rate over to the start of the approach. So notice too that because we have this open or soft boundary, the tool actually does go through it. We can see that is actually the case. And because this is a hard boundary, the tool does not go through this. And there's actually an offset on hard boundary. We've actually got a 10,000ths offset on this for a finishing pass around this large island here that we'll do when we machine this step that goes all the way around it. Let's go and look at our material removal simulation, full video replay, just to see that we're not missing anything, that there are no collisions or gouges. Let's go ahead and play it through, speed it up a bit. There we go. So we've machined the first open pocket on this part of the part. Looks good. No collisions, nothing that's where the tool is gouging or running into the part. Let's go ahead and hit OK here. And go ahead and save your file, and in the next video we'll start looking at the other pocketing operations that have to happen below that.